Okay, so here we're going to talk just a little bit about extreme events, change in migration patterns, and growing season, as I mentioned before. So extreme events, as you guys have heard probably since you've been coming to school here, have been increasing, particularly in the Northeast. We're talking about heavy precipitation, but other places in the world we're also talking about heat waves, tropical storms, and hurricanes. So this is a map of the US and how extreme events are changing. So this is observed change in very heavy precipitation over this time period from 1958 to 2012, and you can see this really large increase in the Northeast of really heavy, this is one-day events. And basically what's going on here is that warmer oceans increase evaporation, warmer air holds more moisture, so there's a longer time in between rainfall events, but then once it actually does rain, there's much more water in the air, so much more water comes out as precipitation in these really heavy events. Other extreme events are heat waves that we're expecting in particular to see more of. Here is just kind of one example. This is the departure from mean summer temperature in Europe, and this arrow here is showing you the 2003 European heat wave, which was a really large event. And this figure, again, is an anomaly figure, so anything above 0 is warmer than average, below 0 cooler than average. And you can see really this trend again kind of starting in around the 80s of this increasing mean temperature going up. And the thing that's interesting is you can kind of see there's always variation around this mean, right? That variation itself isn't really changing that much. It's just the mean that's increasing. Okay, so this European heat wave, without accounting for this increase in mean temperature, is a 1 in 10 million year event. Hugely unlikely, it sounds like, right? But after accounting for this increase in average temperature, it's really only a 1 in 100 year event, something much more likely to happen. So it's not just global warming and it's not just natural variability, but it's both. We're increasing that average temperature, right? You're seeing this average temperature line going up, plus that variability. That variability hasn't changed that much, right? You see these sort of large departures from the mean, but it's the change in both of these things, or it's the change in the averages with the variability on top that's giving us this real increase in extreme events. So here is real data in black. The red here is computer modeling simulation showing us going into the future. And as this sort of average temperature rises, these sort of quote unquote extreme events like this 2003 event become way more likely and much more frequent. You can see by 2050, it's really an average year. And by 2100, we're looking at it as a relatively cool time. And this is another way that Hansen et al. Decided to look at temperature anomalies over time. This is sort of our distribution. So this is the mean between 1951 and 1980, with anything over here in blue being considered a cool period, anything in red over here being considered a hot or extreme like heat event. Okay, so we can look at how this distribution changes over time, and that's what this little video is going to show you. Assuming it will play. Media not found. Okay, so I will try to find that and post it for you guys. Okay, so we also have increases in extreme events driven by warm ocean temperatures, high humidity, and low wind shear. So wind shear is when wind is going in opposite directions within the atmosphere. So maybe in the lower atmosphere it's headed west, but in the upper atmosphere it's headed east. So that sort of wind shear is what that's called. It sort of takes the energy away from hurricanes and tropical cyclones. So we know that both of these things that I've highlighted in red are actually increasing with climate change, right? Warmer oceans, higher humidity in the air. But higher wind shear, people don't really know so much if this is happening or not so much. They think it might actually be increasing. So that would be sort of the one thing combating against more or more intense hurricanes, if that's actually increasing. All right, so it's unclear at this point if the frequency of tropical hurricanes and cyclones was increasing, and that's largely because it was a long period of time where people weren't really keeping that close track of them. There weren't that many people around, so we weren't able to know when all of these hurricanes were happening, whereas now everybody's very clear on when they happen. There are a lot of people around, a lot of people gathering data, so we don't know if that's just sort of an artifact of people keeping better track at this point. But we do know that the intensity is increasing, and this is showing you this power dissipated as sort of an index. It's a measure of storm intensity. It has to do with wind speed and how long the storm goes on for. And the thing that you can really see really clearly in this figure is this is sea surface temperature in blue, and this is the relative power of these storms in red, and they track each other really closely. So warmer oceans, more intense storms. Okay, so changing migration patterns is something else that I think is really interesting. There's some nice data on it. This is a figure in the change in latitude of bird abundances, so taking into account 305 common North American bird populations and seeing that they are actually moving north. So this is the average distance moved north in miles from where they had been between 1966 and 2000. And so that's the mean there. And then moving north here. These are data from a meta-analysis. It's sort of a complex meta-analysis, but the basic idea is that they looked at all of these different groups of, in this case, spiders, ground beetles, butterflies, and grasshoppers, and the like. And so this is sort of their distribution, and this was the mean. So if they had been moving to this side of the mean, they would be moving south. If they're moving to this direction, they're moving north. And what you can see in all of these pictures is that everyone is moving north at about 17 kilometers per decade. And they also found migration at two higher elevations at about 11 meters per decade. So these range shifts are years. The years compared did vary by experiment. There are about 23 experiments. So there's more detail if you want to kind of go in and take a look at this. But this is the basic take home from this paper. Growing season also increasing. I think you can see that really clearly in the Northeast here. Excuse me. So on average, spring is about 3 days earlier. You can see that variation across the U.S. here. Here in Vermont, we're looking at about 5 days earlier. And I don't think anybody's going to argue with that. I think spring has been coming pretty early around here these days. We're also seeing autumn falling back, becoming sort of later and later in the year as we go from the 80s to more current. And then we're also having a longer frost-free season, and you can see that really all across the U.S. and the Northeast, we're looking at about 10 days longer of a frost-free season. So good for growing things, maybe not as good for skiing. So to all of these sort of standard things that people talk about, I just added a few here that we hear a lot about. Extreme events, changing migration patterns, and increases in the growing season length. So that's it for indicators, and